Welcome to the latest edition of our Defense Developer webinar series. I am Gary Schofield and I will be your host today. Today's webcast will be focusing on building analysis into your applications. Our speakers are myself, Gary Schofield. I am an account executive on Esri's Defense C4ISR team, and I'm also Esri's Commercial Joint Mapping Toolkit Program Manager. With me today, I have Carrie Robinson, who is Esri's Product Owner for Defense, and Eric Bader, a Product Manager for ArcGIS Runtime. Our agenda for today is a brief introduction with our main focus on analysis capabilities in ArcGIS Runtime, and then we'll have a brief period of summary and questions. In our last webinar, we talked about the benefits of using a GIS and the modern architecture of a web GIS in our C2 and intelligence systems. As we move from analog and paper systems to digital systems, it's important not just to digitize these existing workflows, but we should also leverage this new medium to transform our approach. Using a GIS, we don't just draw items on a background map. Instead, we maintain geospatial feature data, which is rendered based on its attributes, and in which you can perform spatial analysis between your military units and plans and other entities and phenomena. This way, you can better understand how your operations will be affected by things such as weather, terrain, enemy units, and their actions and plans. Spatial analysis allows you to understand your battle space by answering questions such as where things are, how they relate, what's the best site or route. Spatial analysis allows us to detect patterns and how things are changing over time. It also allows us to make predictions and test those predictions. For example, we can use past behavior and doctrine to predict likely enemy locations and movements. Spatial analysis is a key component of the ArcGIS platform. ArcGIS includes hundreds of tools and is designed to integrate other analytical tools as well. ArcGIS allows us to perform these analyses in a variety of clients and applications, whether you are in a desktop, web, or native device applications. Today, we're going to specifically focus on the spatial analysis capabilities of ArcGIS Runtime, which is designed to support your development of native applications. We're going to cover these 5 areas of analysis in Runtime. First, we have visual analysis, which is to leverage the GIS to render our data and maps to support specific workflows and understanding. Next, we will talk about some newer capabilities for high-performance visibility analysis. ArcGIS Runtime includes a robust geometry engine to enable rapid calculations on the relationships between spatial features as well. In our native clients, we can also perform network analysis to find the best routes, closest facilities, and services areas. And finally, ArcGIS Runtime can take advantage of the wide breadth of ArcGIS's spatial analysis tools through geoprocessing. So let's get started with visual analysis. Visual analysis is about leveraging the GIS to render your data in different ways based on the attributes and your rendering rules. It allows you to highlight important features or assist the user in identifying patterns and outliers. A good best practice is design your web map in ArcGIS Pro to display information in an appropriate way for your application. Runtime then allows you to expose tools to your user to modify this to support certain workflows. When it comes to vector data, we will use the attributes to drive symbology. We have many different renderers, whether you want to do unique value or class breaks to accentuate and show different data to the user. We can also leverage Esri's extensive smart mapping capabilities directly in Runtime, so you can create beautiful maps that really represent your data and allow the users to understand the information you're trying to convey to support their needs. For raster data, the real power here is that we can apply rendering rules to the raster on the fly in order to visualize it. There's no need to run the raster through a process and save it as a new file. So let's take a quick look at some of these capabilities. Here I'm in our ArcGIS Runtime SDK.NET samples application, where you can take a look at different capabilities available to you and some of the source code. So you'll notice each of these samples has a live sample that you can play with, as well as description and the source code that goes along with it. So let's take a look at feature linear rendering. Obviously, with this parcel data set, I've highlighted some delinquent parcels in red, or I can just override that symbology and just show them all with a blue outline. Or maybe I want to do something like, take the county layer here, which is just a black outline, and actually understand it based on population of those counties. I can also do things in 3D by using things like feature extrusion. So you see here the states symbolized based on their total population. But if I want to see that by population density, you can see a major change in how those are symbolized and what the user takes from that visualization. When we look at rasters, you might look at this elevation data set, which can't see very well, but once I apply the hillshade, you can see it. I can also change how that hillshade looks on the fly. And then finally, I can do things like, say, this elevation set here, where I can look at things like the hillshade, or I can apply a color ramp on that as well. And then finally, I may even want to do something a little bit different, which is to look at the aspect of those pixels and visualize it in a slightly different way. While this is a pretty simple approach, it can be pretty powerful in providing analysis capabilities to you. In this example, I'm taking weather observations and I'm trying to understand how they're going to affect my operations in the various areas. So instead of running it through some complex analysis, all I've done is basically set a render rule on each of these observations where if they exceed certain thresholds of temperature or cloud ceiling or these different things, they'll show up as either green, amber, or red, whether it's good to do things like cross-country mobility or how much the weather is affecting my air defense systems or personnel or UAVs. So it's a really powerful yet simple way to take advantage of analysis in a GIS. Now I'm going to hand it over to Carrie to talk about exploratory analysis.
Thanks, Gary. Okay, so what do we mean by exploratory analysis? It's really just another form of visual analysis, but in 3D. And the aim is that it's high performance, so it's driven by the GPU on the device itself. The results are just displayed on the screen, so they're not persisted. And it acts on the resolution of the data that's being drawn to the GPU itself. So it doesn't have to go back to the source data in order to make those calculations, which is what makes it perform so quickly. Also, exploratory analysis is cross-platform, so it takes advantage of the GPU on the device, so it works on many different platforms, and it works in all of the SDKs that Runtime supports, whether it's Android or iOS or Windows or Linux. These tools will work. So exploratory analysis tools are really well suited for visibility analysis, and we have two visibility analysis tools available in ArcGIS Runtime. We have line of sight and viewshed. We'll start off with line of sight. So line of sight really gives you a visual indication of where an obstruction might occur on a sight line between two objects, between a target and an observer. So it shows you what the visible portion is and then what the non-visible portion is of that sight line. And then it displays it using different colors. We have two varieties of line of sight in the API. There's location line of sight and geoelement line of sight. The location line of sight calculates against 2 points, so two geometries or coordinates that were given to it for the target and the observer. We also have the geoelement line of sight, which calculates it between two geoelements. Now, a geoelement in ArcGIS Runtime is either a feature that's part of your data layer that you've loaded into the application, or it's a graphic that's being drawn to the display. But the advantage of the geoelement line of sight is that you can attach it to these two geoelements, and as their positions update based on the data or something else that's driving the position of that geoelement, the line of sight calculation will update automatically as well. So you don't need to redo that calculation. The API also will trigger an event when the target is visible. So you can keep track of, for instance, how many observers have visibility on a specific target at any particular time. So just to take a look at some example code for line of sight. In this case, we're creating a location line of sight. We're giving an observer point and the target point, which you can see being constructed here based on some coordinates. And we add this to an analysis overlay. So we create an analysis overlay in our app, and every time we create one of these analyses, the either line of sight or viewshed, we can append them to an analysis overlay then. So we append it to the analysis overlay, and once we've done that, we can just make sure that the line of sight is visible and it will draw to the display. But we can also configure some parameters for line of sight as well. So we can change what the visible and obstructed color is, and we can change the line width as well. So in this case, we're changing it to cyan and magenta and setting that line width. So we try to keep it as simple as possible, but still very powerful. So for viewshed, this really determines what the visible and non-visible portions of a surface are based on a single observer point. So those visible and non-visible portions are displayed using different colors as well, like the line of sight is. And we also have a location version of viewshed and a geo-element version. So the location viewshed, you can either just give it the camera, so what the camera is of your 3D view that you're using, and it'll create a viewshed based on that. And then you can move away from that camera angle and then see what that viewshed was. Or you can just pass it in a point with an X and a Y and a Z value, and it'll construct the viewshed from that. Then there's also the geo-element viewshed, which allows you to attach it to a geo-element. So attaching it to a feature or a graphic, and then similar to the location, to the geo-element line of sight, then it updates as the position of that graphic and feature updates automatically. You can also change several parameters of your viewshed. So you can give it a horizontal angle, so it could be 360 degrees, or it could be less than that if you'd like. You can change the vertical angle, the pitch of the viewshed, the minimum distance, the maximum distance, all those sorts of things. So to look at a little example here in C++, we construct a location viewshed, giving it a point that's already been determined in this case. And then we can pass in those parameters that we want to set to adjust the viewshed itself. We want to make sure that it's set to visible so that it draws to the display. And then we can append it to that analysis overlay. So very, very simple. You also have the ability with viewshed to draw the frustum. So if I move back to this previous screenshot here, you see that there's a frustum being displayed, so you can actually see the full field of view of that viewshed that's taking into account, which might be useful in some scenarios. Okay, so let's look at a demo of viewshed in action. So first I'll show creating a line of sight. So I'm going to create it from a set of observers. If you can see these, I have several black points that are drawn to the display from a shapefile that I've loaded into the app. So once I set that, it's creating these lines of sight from these observers to my own position, which is being simulated in this app with this blue graphic here as it moves around. So we can see that these are actual sight lines direct from the observer to the target, which is why you don't see a portion of it here, because it's actually just going through that hill. But we can see when I'm visible and when I'm not, based on whether the line is green or red to my position. We also can see up here in the upper right-hand corner how many observers I'm visible by at any point of time. So that's using that event that's being triggered. So I'm currently visible by 2 observers. Now, in order to do a viewshed, there's several different ways that we show in this application to do that. So I could actually just long press here on the map. Oops, I selected the wrong thing. Okay, and select viewshed, and it'll create a viewshed right at that location using some default parameters. So it's creating this 360-degree viewshed. But I can also bring up the viewshed tool and just create one that follows my mouse location as I move it around the display. So you can see it updating here in real time as I move it around. And maybe if I get to an area that I like, I can save it there. And finally, to show an example of a geo-element viewshed, I can attach one to my current location. So it's now being attached to my simulated location, and it's being updated automatically as that position updates in real time. But I can change some parameters as well. So I can change that distance of the viewshed if I'd like. I can also say that I don't want it to be a 360-degree viewshed. Instead, I can change a minimum and maximum distance. I can change that horizontal angle to something else, and I can change the vertical angle as well. So there's several parameters that can be set. and go ahead and save that. Now, when I've saved that, what that's done is it's constructed that and it saved it to that analysis overlay. So here we have a list of those, the view sheds that I've created. If I'd kept that line of sight on, and it would display all those lines of sight as individual analysis overlays in this list as well. So at this point, I can turn them on and off. I can zoom in, remove them, etc. So it gives you the ability to kind of manipulate each one of those individually. Now, I'm using the Dynamic Situational Awareness example app that you've seen us present in previous webinars. So some of you might recognize it. This is an open source app for developers to use as an example for building apps that require situational awareness in disconnected needs. So you can find more information about this app on the developers.arcgis.com and have access to the code on GitHub. So with that, I'll hand over to Eric.
Okay, thanks, Carrie. That was great. So now we're going to turn our attention to, for developers, a really powerful analytical capability within the runtime that not many developers or users know about right off the bat, but it's really quite a hidden gem, and it's the foundation for a lot of spatial capability for analytics that you can put in your applications straight away, especially for real-time situational awareness applications. The geometry engine class is quite powerful. So what is the geometry engine? So this is a static class within all of the runtime APIs that contains within it a myriad of geometric operations and geometric query functions. It operates on point geometry, line geometry, polygon geometries, and geometries that come from both features that come from the ArcGIS system, or graphics that are maybe ad hoc or created within your application on the fly. So these operations work off geometries from both of these types. And the geometry engine executes these functions completely in a disconnected environment. So it runs in memory and process of the application, and there's no need to really call out to a local service or remote service to perform these quick and simple geometric functions. So the geometry engine groups these functions into three separate groups. So you can get the dimension information about a geometry and ask questions of that. The geometry engine gives you the ability to ask spatial questions to a single geometry or many geometries all at once, and provides functions to actually create new geometries from many of these functions. So what are geometry dimension questions that could be asked? Though, let's say you have a path that you're traversing through on a mission field. How long is the trail that we're going to follow? What's the area of the polygon within which we traverse? Or am I inside of this polygon? What's the boundary or extent of this particular region that I'm within? Or my location is here, but where are the locations of my my fellow members of the mission that I'm participating in? So what's the distance between us at any given time? So here's a piece of code that demonstrates how to get the planar distance between 2 points. You simply utilize this singleton geometry engine and calculate the distance between those points. What else can you do? So the geometry engine has the ability to transform and project geometries from one spatial reference to another. For example, it has a project method. And as you can see here in this piece of code, this example shows the geometry engine calling the project method by passing in a point that's in Web Mercator and then projecting it to an Ordnance Survey coordinate system of Great Britain. And transformations are just basically handled for the best transformation for that particular region of the world. The framework provides that, but you can override that and specify your own transformation within ArcGIS Runtime. Pretty powerful. You can also answer spatial questions about specific geometries, and you can test for conditions between geometries. This is very important for, like, let's say you're wanting to implement a geofencing capability where a point needs to behave differently if it enters in or crosses into the boundary of a polygon, or geometries intersect with each other. We want to get that, we want to test for that. If these two things intersect, we want to be able to handle that. And so here, the polygon will change in this piece of code here if a polygon and a polyline geometry crosses each other. Many of these functions create geometries and return geometries back from as a result of the test. So for example, if you're going to buffer a point, you're going to keep that point, but you're going to return the polygon buffer of that. Or if you're going to union two polygons together, you're going to get the result that's the total single geometry polygon of that union. The same with difference and intersect. The powerful thing here is that when you perform these geometric operations that give you a result, you can take those geometry results and pump them through another function and use those straight away. So you can chain these functions together to really solve a specific scenario that's happening in the field in a situation. There's a lot of other functions that you can take a look at, and I encourage you to look at the API reference for either .NET, Java, Android, iOS, macOS, or Qt to look at the Geometry Engine API and see all the different functions that are there. There's a lot of them. Here's another example of something that most people wouldn't think of, but if you want to label a feature, let's say on the map, you want to label it in a specific centroid of that particular polygon, you can get the label point, the best label point that the system will give you for that particular feature. So let's take a look at a couple of demos. You saw Gary demonstrate a few things within the .NET sample viewer. This is the ArcGIS Runtime SDK for Qt sample viewer. And it hosts a number of different samples and examples of not just geometric operations and the use of Geometry Engine, but all kinds of functions that you can perform in building applications with the runtime native applications. And as he mentioned, you can see the source code, and this is available freely for download on arcgis.com today. So you can grab it today and run it straight away without having to install the runtime itself. So in this example here, I've got a map, and if I click on the map, I will use the geometry engine to get a buffer on that point, but not only return the planar buffer, but also the geodesic result of that buffer. And so that's one example. Here is the ArcGIS Runtime SDK for Java sample viewer, also available to download. And here are a number of different geometry engine functions that you can test for. Here's one that tests relationships of different geometries. So if I select this polygon, I can see what the conditions are for the other adjacent polygon or geometric features, such as a point. And in this case, the polygon contains the point and it intersects the point. And with respect to the linear polyline feature, it crosses and intersects that selected polygon. If I select the actual linear feature, I can see its relationship to the polygon and point. Polygon, it crosses and intersects, and it's disjointed from the point. So this could be very handy in testing for specific situations in the field if your applications are reporting information back. Here's some spatial operations between two polygons, right? If I want to get the difference between these, I'll get the two polygon pieces that are different between the two, and I can perform another intersect, let's say. So I get the red polygon that's the intersection of the two. I mentioned that there's a powerful coordinate system transformation and project capability within the geometry engine. So if I click on a point here, I'll see the original point in Web Mercator, but I'll also get the point projected immediately in geographic coordinate space, WGS84. it's pretty important in some cases to if you're going to do a let's say an antenna coverage analysis or a projectile landing zone, to be able to construct from coordinates, construct a sector. And that's what this demonstration shows that the runtime can do with the geometry engine. And you can change these parameters on the fly, and as the situation changes, you can define the sector differently as well. Very, very powerful tools. And of course, being able to take into account the curvature of the Earth in calculating your geometric operations. We can see this demonstration of how to calculate and get the results of a distance between 2 points in geodesic. So if you're going to do great circle type analysis, you can do that. And one other thing, you can manipulate geometries on the fly if you want to take and densify or simplify certain geometries. You have the capability of doing that, or defining the different segment lengths between geometries and manipulating them that way. So a lot of different powerful tools that you can use with the geometry engine. And so that's all I have for now. I'm going to pass it back over to Carrie to take us into some more deep analytical capabilities within the ArcGIS runtime.
Thanks, Eric. Yeah, so the geometry engine really has these kind of key core capabilities that we need in order to do maybe some further spatial analysis, which really makes your GIS application come to life. So some of the functions that you might have seen Eric show might seem very basic, but actually they're really powerful, and they're key and critical to spatial analysis. So what I'm going to show here is an example of how you can use the geometry engine in an app. In this case, we're using the Dynamic Situational Awareness app, and we have these real-time streams of information that we're coming in and visualizing, and we want to analyze them in real time. In this case, what we've added in is the ability to create rules, which will be carried out against these real-time feeds. In this case, we have our Blue Force tracks, and we have some situational awareness events that are coming in. We call these rules conditions, and these conditions are constantly evaluated. And when a condition is met, then it triggers an alert, and the user is notified in the app. So we can create different types of conditions, whether they're attribute conditions or spatial conditions, and that's where the geometry engine comes into play here. So in this case, the app comes with a pre-built condition. We see that we have an alert here on the left-hand side. If I click on that, we see that there's a distress alert. One of my teammates is signaling that they're in distress. We can see their kind of icon being highlighted here in red to signify that it's in distress, and now I can take that and act on it. But that is not taking into account the geometry engine. That's just checking to see if its status is of an alert or not. So I'll create a new condition here to show you an example of one taking advantage of the geometry engine. I can set a priority. So in this case, I want to say it's a high priority. And then this is where I say I want it to be a spatial condition. So I'll give it a name. So what I want to do is I want to be able to understand when the situational awareness events are occurring within this particular area of interest, or actually within any area of interest that I have loaded here from this shapefile. So I'll give it a name, events in AOI, and specify my source feed. So it works against one of those real-time feeds that's coming in. So I'm going to use the situational awareness events. And you can do two different sorts of spatial analysis. So you can either do a geofence type of analysis where you're saying alert me whenever an event occurs within an area, or you could say do a proximity type of analysis. So it's within a certain distance of something else, right? So in this case, we're going to do a geofence. So we're going to say whenever those SA events occur within any of the objects from that AOI shapefile. So I could choose a particular one. In this case, I'm just going to say all of them and click next, and I can review up here what that condition actually was. And once I create that, we see that we have the condition here, but we also see now that these events that are within that AOI are now also flashing red. And in my list of alerts, we see that we have several events that have occurred. So these are conditions that are using the geometry engine to evaluate that real-time feed as it comes in. It's a pretty simple analysis that it's doing, just a point and polygon, but it proves to be very powerful for these sort of real-time alerts that you need to create. Okay, with that, I'll hand back over to Gary.
Thanks, Carrie. Now let's talk about network analysis capabilities in ArcGIS Runtime. So, network analysis allows us to optimize routes between locations. We can optimize this for different parameters such as speed, distance, or even things like cover and concealment. We might also need to utilize other things like load class restrictions, or maybe take things like normal traffic patterns into account. Other analysis we might do is, where's the nearest facility? Where's the nearest hospital? Those kinds of questions, and how do I get there? And again, we've added other tools recently for things like service area calculations, which allow us to understand the reach of a certain unit over various time intervals. For instance, if you're planning out rapid response capabilities, you want to know, how far they can get in certain amounts of time. Or a really useful part of this is things like, hey, this unit was at this position at this time, how far could they have gotten in a half an hour or an hour or whatnot? So you can do search and rescue, or be identifying an enemy location or anything like that. So network analysis in ArcGIS Runtime is handled by tasks. Then there's 3 different tasks that you can take advantage of: the route task, closest facility, and service area. These tasks are objects that perform these operations, and they're pretty simple to use. One thing that's important to understand is that we're not really going to show the difference, but basically these tasks work whether you're working with online data through maybe a network, a service that's being provided by an ArcGIS server, or whether you have local data deployed to your device. So if you need to route or do any of these operations in the field without a connection to your server, you can deploy your data, your transportation network, and the solver through a mobile map package to your device. What's also interesting about this is, more than just taking normal commercial roads like you're used to using in your own phone, you can actually deploy your own custom types of geometry, whether it's things like your main supply routes, or whether you've been able to capture trails and other private or non-commercial roads that you need to use for your routing. You may even do things like using GPS tracks and other information to augment the roads that you have collected before to get other routes that are available. These tasks all support barriers, so you can model things like bridges being out or no-go enemy areas to avoid. And you can bring in things like time and traffic as patterns. As you can see from this sample, it is simple to work with these tasks. You basically load the object, provide the parameters, run the tool, and get the result. So we're going to go ahead and look at our samples again to get a sense of these capabilities. This is just a very simple sample of how do you route from point A to point B and get the driving directions for it. Again, you've got the source code available to replicate that, and then you would obviously make it more complex with inputting parameters and other things. I want to look at another thing where I'm actually looking at closest facility. So if I click on the map, where's the closest hospital to my location and how do I get there? So this can be very useful for allocating resources and understanding the best way to get to a resource that you need. The other one I find very useful is service areas. So when you're looking at maybe last known position and how far they could have gotten, or you're looking at allocating and forward deploying units to be able to react to certain situations, you want to be able to use these tools. So let's look at placing a facility in this location, and let's take a look at its service area over time. Let me reset that. I think try it one more time, and then we'll chalk it up to bad luck. So that's working with network analysis tools. Right now, I'm going to go ahead and pass it back to Carrie to talk about geoprocessing.
Okay, thanks, Gary. Okay, now we get to geoprocessing, which really, when you think about ArcGIS and spatial analysis, it's really the heart of how we, the power that GIS can bring to your system, right? So the geoprocessing is the framework and the tools for processing spatial data in ArcGIS. And the tools are broadly categorized into two kind of buckets. So we have spatial analysis tools, and then we have data management tools. And we have several extensions that you can also use within ArcGIS that provides many different analytical tools, depending on what that extension is, whether it's 3D analysis, network analysis, like Gary just showed, those sorts of things. So really at the heart of ArcGIS, the tool that we use to author and manage these is ArcGIS Desktop. So there's over 1,200 built-in tools that are included with ArcGIS that you have access to within this system. And you don't need, you can just use those tools individually, but you can also string them together into workflows using Model Builder, or you can use Python scripts as well. So you can take all of the data and the knowledge that you have. You can use these tools to wrap it all up into a powerful processing package and then make it available to many different clients to take advantage of. So that framework gives you a set of standard tools within ArcGIS that you can just run individually, but also you can create custom tools. You can bring in your own custom tools that you've written and incorporate them into these workflows built using a model-driven approach with Model Builder, or scripting using Python. And these can become very powerful. They can be very simple, or they can be very complex. Once you've used Model Builder or Python to author that analytical workflow that you've defined, then you can package it up into what we call a geoprocessing package. And then in order to publish it to ArcGIS Enterprise, you can publish it to ArcGIS Enterprise, and then that makes that geoprocessing package available as a REST endpoint for any client to access and then use and take advantage of. You can also package that up to be used in particular for an ArcGIS Runtime application. And in that case, it would use ArcGIS Runtime local server to execute that package locally on the device itself. And these geoprocessing packages then can be run either synchronously or asynchronously. So depending on your workflow, you can spawn off that process to run. You can do some other work, or you don't have to hold up your user interface. And then when that job is done executing, then you can use that result in your application. So what is the ArcGIS Runtime Local Server? Well, it's the tool that allows you to integrate these ArcGIS Desktop workflows into your own application. So it provides a subset of the tools, of geoprocessing tools, so approximately 300 of the data management, the spatial analysis, and the tools you get with extensions that you can install and run. The result must be packaged from ArcGIS Desktop, so from ArcGIS Map, ArcMap or ArcGIS Pro. That package then also includes all of the data and all of the information that it needs to execute that tool. And it executes it as a local service running on your device. So it's similar to how you would execute a geoprocessing service that's hosted in ArcGIS Enterprise, but it's actually running on your own local device. So that input data, the project data, the output data is all there as part of that package. And then this works with all of our SDKs that run on desktop platforms. So whether it's .NET, Java, or Qt, that same geoprocessing package will work on either one of those, with either one of those SDKs. And then the API that we provide for local server includes other things such as administrative tasks that you can run. So you can tell it to go ahead and start up a geoprocessing service, start up the server, stop it, those sorts of things. So I wanted to give you a few tips on some key things that's important to know when you're running geoprocessing services, whether it's from a local server or from ArcGIS Enterprise as a web service. You can find a lot of these tips here if you go into our ArcGIS Enterprise server help page here, server.arcgis.com. There's a section there for performance tips for geoprocessing services. So I'll just summarize what some of those things are here. One of the things you can do is if you know what the data is that's going to be your input, just restrict that data size to only the area and the amount of data that you need in order to run that process. This helps get that geoprocessing package down to a smaller size, or that service definition that's run within ArcGIS server as well. If you can, use local data. So if you can actually host that data on the device that's actually running that process, obviously that will help a lot with you know, less network traffic and help with the performance of running that geoprocessing service. Also within that workflow, as you kind of go, you know, through each step within your script or that model that's being run, make sure you write that intermediate data to memory. You don't need to necessarily write that to disk. We have a way to use the memory of the device in order to do that. Also, there's standard kind of ways that we provide for you to add attribute and spatial indexes to your data. So make sure you do that. That'll help with the querying and the accessing of your data that you're using for the analysis. Also try and avoid unnecessary coordinate transformation. So if you are in control of the data that you're using, then you want to make sure that you have all your data in the same projection, so that doesn't need to do coordinate transformations as part of that analysis. That definitely saves a little bit of time when the tool is running. Having said that, if you need to keep the data in its native projection, you can do that, and you can add in that coordinate transformation as part of the process, which can also be very powerful. Finally, think of other ways that you can reduce the data size. So if you're using some spatial data or tabular data in your analysis, but you don't need all of the attributes as part of the analysis, try and normalize your data a little bit so that only the information that's in there that you need is there for the analysis, because this will also help a little bit when it comes to the indexing of your data and using it. So there's also several other tips on this webpage. If you're looking to incorporate geoprocessing into your apps, I highly recommend you go to that page and take a look for some best practices. Okay, so let's move on to a demonstration of geoprocessing within Runtime. I'm going to start off by showing you an application that's been built using geoprocessing. And then I'm going to go back and show you how the tool, what the tool is that I used, how it was written and packaged using ArcGIS Desktop. So this is a .NET application. It's fairly simple. It provides you with a tool to just add a line and then generate a terrain profile from that. So we see here that we have this elevation profile, and as I move my cursor along, I can see not only the altitude of that particular location, but I can see what its position is from the start. So there's a couple of different things that are going on here in generating this terrain profile. Now in this case, I could be calling out to a geoprocessing service that's being run and hosted in ArcGIS Enterprise, but in this case, I'm actually just using our local server. And so it's all running on my device here. And the tool that's being run just produces that end result line with all of this elevation and position kind of information in that line itself. But the app is what's generating the elevation profile. So that's not part of my GP service. So that's an example of calling my geoprocessing tool, getting the result, and then doing something else with it in order to present it in a nice way to the user. Okay, so now let's take a look at how I created this geoprocessing tool and this geoprocessing package within ArcGIS Pro. So ArcGIS Pro is the kind of premier geospatial analysis tool for ArcGIS. So we can see here that I have a huge list of various geoprocessing tools that I have access to. So we're going to start off here in the Coachella Valley, where I want that analysis to be run. I have my elevation data set, which I'm going to use as a source of generating the elevation data and the terrain profile. And notice that because I'm really only interested in this area, I've clipped this elevation data set just to this extent. So that's one way of making sure that the tool performs a little bit better. And I have here a toolbox loaded into my project, and that toolbox contains a script that I've written in Python. It's a really simple script, as you can see. All it really does is call two different tools. So the first geoprocessing tool that it calls is interpolate shape. This comes from our 3D analyst extension, and it takes that input line and then that input elevation data set, and then interpolates it and generates the elevations for each one of those points along the line. And then create routes is actually from our linear referencing toolbox. So it allows you to given those points along on the line that was just interpolated, it then provides you with the distance from the start position along that line. So that's how we're getting the distance. And then we take that output line and we send that back as our result from the geoprocessing tool. And then that's when the runtime application can pick it up and present it in a nice way to the user. So in order to package this up, there's a few things I need to do. First, I need to run the tool. So I need to run the tool so that I can get a result back, and that's what I end up using to publish and share within the runtime environment. So I'm going to run the tool. This line that I create here doesn't have to be one that the end user uses. It's just any old line that I can use. I'm going to point it to the world elevation data set, that clip data set here as the source, and run it. So it's running through that script. It's calling that the interpolate shape geoprocessing tool, and then it's calling the create route. And what I get back is this line shown here in kind of this purpley color. And that line is what the runtime application can take. So now that I've run that tool, I have a result. I use a different geoprocessing tool now to actually package that up and provide it to runtime. So we have a tool called package result, and that's in our data management tools. So I can see here a list of all the tools that I've run. So I've only run this one this morning. So it knows that result. I need to give it a name for the output file. So I'll just call it interpolate shape. And that'll be the name of the geoprocessing package. The key thing to note here is that I have to check this box that says support ArcGIS Runtime. And what this does is it tells it to package it up in a way that all the data is in the right format that runtime understands. And it's all packaged in a way that can be easily used within runtime and local server. I can provide some other information here, such as a summary and tags. If you want, you can take this package and upload it to ArcGIS Enterprise or Portal, so then it's made available for other people to use. Maybe it's an authoritative or designated, this is the tool that I want the rest of my team to use. You can do that as well. But in this case, we're just going to create that package and we're going to save it on disk. So I'm running this package result here. And so it's preparing the data, now compressing the package, and now it's completed successfully. And what I can see is that here it's just created this GPKX file. So that's the geoprocessing package file. And that now is the file that I can point my ArcGIS Runtime application to in order to run that using the local server and provide that result. Okay. So that's it for geoprocessing. I'll now hand back to Gary to summarize.
Thanks, Carrie. Today we have talked about many ways to perform spatial analysis in your apps built on ArcGIS Runtime. These tools include visual and exploratory analyses such as fast line of sight calculations, or more conclusive analysis using network analysis, the geometry engine, or geoprocessing. It's important to understand that often your users will need tools and workflows that combine several tools. For example, the alerts Carrie showed use the geometry engine and some visual analysis to highlight information to the user. Or you might use a service area to then select other features on the map, like what units are covered by this medevac. That's if I put it here. As we have discussed, Runtime supports both offline and online workflows, so you can decide where to provision your data and tools based on your needs. In fact, our next seminar, which I'll talk about in a minute, is going to get really into how to work with offline data. But that's it for today. I want to thank you for the time you've spent with us, and I hope it was very useful to you. And if you have any questions, please submit them into the Q&A component. We'd be happy to answer them now. Or again, please reach out to us. There's going to be a survey that comes up after you close the webinar, and we would really appreciate your feedback on the session. And if you would like us to contact at all, it'll ask you that as well. So please let us know how we can help. So this is a whole series of webinars we've been doing. We did a couple that are already posted up. You're welcome to go and check out those videos if you missed them. And like I said, this one will be available in the near future. You'll get an email, and please have a look at it again or share it with your coworkers. And I encourage you and any of the people you work with to sign up for our next webinar on October 17th, where we're going to focus on how to work with offline data in runtime. So basically, how are you going to package up data and make it available for things like analysis or visualization and these kinds of things. So I, again, thank you for your time, and I hope to see you next time. Take care.